We continue our sessions today with Ying Tong, who is going to talk about the difficult topic of standardizing zero-knowledge proofs when we have so much going on in the space, progress and looming clouds, etc. Just to, I don't know, I don't want to to add additional stress, but this is high stakes. Okay. What we're going to do after these sessions is have a discussion with the steering committee of ZKProof to understand the role of this organization in proposing the next standards and interacting with all the standard bodies that also you're going to describe. It already was difficult beforehand, managing the pace of progress and understanding where to stop and standardize and when to progress. There's already been attempts, right? Verified verifier to bless a particular verifier that actually didn't end up creating a verified verifier. So it's really not an easy topic to standardize. So have a listen to this talk, ask questions, and bear in mind that an outcome of this is then concrete next steps with all the standardizing organizations.
Thank you, John. And I've structured today's talk as an interactive conversation because I think that's the best use of our expert audience and your time. So my name is Ying Tong, and I work at Ideal Group. Previously, I was at Zcash and the Ethereum Foundation, and I've had experience with digital identity and interacting the EU digital identity standards. And in the process, also helping out with ZKProof standards, interacting with standards bodies like IETF, W3C, Linux Foundation, and more. So today we're going to go over the existing efforts to standardize zero-knowledge proofs, and we're going to be collecting feedback, questions, suggestions from you. So I've structured this as a series of questions, and my idea is that for each question, we'll have a short open discussion session, and I want to capture it on the mic. So the first sort of motivating question is why standardize? And my claim here is that zero-knowledge proofs are being increasingly widely adopted, but in an insecure way. So right now, there's, as of this morning, $7 billion being secured by the top 10 ZK-proof systems in ZK rollups. But we find bugs all the time in these already deployed proof systems. Very common class of bugs is Fiat-Shamir bugs. I'm sure you're aware. We saw yesterday's talk, Justin Drake mentioned that Google used SP1's ZKVM to prove in zero knowledge the efficiency of their algorithm for easy point addition. Oh, we're going to edit the slides live. Yeah, thank you. So, yeah. And like a few hours later, Trail of Bits found several flaws in Google's guest program, and just, I think, lack of understanding of how to use SP1 ZKVM, and they managed to forge a proof that passed Google's own verifier, but with like a faster algorithm. This is just a fake proof, and yeah. And then I think potentially the biggest deployment that is coming up is digital identity. So the EU Commission has already been talking with like Google, Longfellow, Vega, OpenAC, Norm. Lots of options that they're considering for the zero-knowledge backend of their anonymous credentials solution. And Google Wallet also announced integration of Longfellow into the wallet. But all this started out in actually misunderstanding by the EU Commission on the invariants and the properties that they need. So even though they stated unlinkability as their requirement, their initial chosen solution was just selective disclosure, which it was pointed out in this comment in 2024 that selective disclosure does not provide unlinkability with respect to the relying party, the verifier, and either with respect to the issuer, the identity provider. So all this is to say that there's large-scale deployments of zero-knowledge proofs already happening, and we're going to see just increasingly rapid adoption of it, and we need to make sure that these are safely deployed. And this is my top motivation for standards. So I want to open up the discussion here and ask for your opinions on why standardize. Should we standardize? Is it too soon? Who's the intended audiences? On what timeline should we be doing this, and so on? Yeah.
Maybe first raise your hand if you were in ZKProof 1. I vaguely remember, there's one hand that vaguely remembers, it was in MIT, right, in 2018. Back then we were thinking, is it too soon? Should we standardize? And that was like the recurring question. Okay, who has a first comment on this? Go ahead.
So I've been talking to EUDI and some of these standards bodies kind of from the other end of commercializing private data. And it was interesting, they not only don't really pay attention to Groth 16 or NOIR, they don't know about it at all. And when I pushed, it's because it's not post-quantum secure, and that's just a hard requirement for anything they look at moving forward, which kind of puts the entire crypto ZK ecosystem in a weird position.
Yeah, I think that's one of the questions that came up yesterday as well in the quantum panel. Like, on the one hand, Groth 16 has been widely deployed already, and there's no standard for it. A lot of, like, SP1 uses it, for example. But on the other hand, if they're going to become obsolete anyway, should we be spending more effort on this new generation of post-quantum proof systems, or can we do both?
I learned something actually from the panel yesterday. There was a comment from Dan on, those post-quantum proofs are so large that just tagging along the classic proof is probably something that we should consider. So we keep the classic all the way until it's forgeable. We maybe not count on it as we move forward into existing quantum computers. But even today, we saw a talk that moved the growth, the next generation of those pairing-based to 700 bytes. So cutting by 2 the size of those proofs. So it might be that we could have, some length of time where we still consider those proofs as part of the system, but next to something that resists the advance in quantum. More thoughts?
I just wanted to add also, sorry? Oh yeah, sorry. No, because there is 2 things about this post-quantum proof system, I guess. The first one is, can we break soundness in a post-quantum way? And the second one is about zero knowledge. So you have some proof systems that also have statistical zero knowledge, even if soundness will not be post-quantum. So maybe it's something to add that if it's still statistical zero knowledge, it's interesting, even if it's not post-quantum.
Yeah, I think so. As someone mentioned just now, a lot of these requirements are originating from the government and or big corporations who are going to deploy this at scale, and that's definitely been my experience as well, talking with EUDI. But it's interesting because they are considering Vega and OpenAC. So Longfellow, I'm not sure if people are familiar, is post-quantum. Whereas Vega and OpenAC use a elliptic curve-based commitment scheme. So it's interesting that the EUDI is still considering Vega and OpenAC.
Another question is so we do have claims of at least verifiable compute that's post-quantum, right? The Fry-based systems and hash-based systems. Are these relevant here, or do we depend? So yesterday also at the panel we heard that for certain size of proofs, you probably can already have pretty solid proofs that are post-quantum, and a whole side of the industry has been focusing on that for a long time. I think maybe this is underrepresented in ZKProof, specifically in the standardizations, but certainly Ethereum gave a lot of thought on Stark systems, and now there's Stu from that line, and then all the Plonky 3 work.
So the EUDI, they actually had a few kind of vague comments on their requirements when it comes to size. So it's kind of vague, but yeah, you can see there's some deployment context they're interested in, such as QR codes, NFC, and BLE, for which size will matter a lot. But then oftentimes when you're just doing like mobile or like over HTTPS, the size requirements are not as stringent as, for example, blockchain, like putting it on Ethereum. So you can see here that there is no strict requirements for performance that they mentioned, but they do provide a bunch of deployment contexts that are interesting. Yeah.
Just for status, do we have working groups or thoughts of working groups on hash-based zero-knowledge proof systems, or the most advanced one is the formal verification of those systems next door?
That's a good question. Not to my knowledge. Yeah, I think there's a lot of interest though. For example, the folks from WorldCoin, they are using Where, I believe, and they're interested, and they're talking with these governments, and they're very interested in producing some spec and standard that is legible to these governments.
I think that these efforts might join and combine once we have the spec of the actual formally proven pieces of code might end up being some version of the spec of a standard, and all those efforts might converge.
Yeah, that was one of my discussion points, is how we can work with the formal verification effort, because very often the formal verification starts with defining certain abstractions and certain theorems that are common across a wide class of proof systems and that are going to be useful in a very modular way. And I think that's definitely one approach that we can take to standardizing generic ZK proofs to reduce duplication of efforts. So that's one of the things I wanted to gather people's opinions on, especially people who have worked on formal verification as well as implementations. Do you see overlap in these efforts, and how can we work together?
I think it might be the case that many of them are right next door, working actively on that field. Go ahead.
Yeah.
Yeah, no worries. I just wanted to piggyback on some of the things you had on the slides, like who the standardization should be for, etc. Like, it feels like there's different levels that need to be tackled. Maybe one level of like democratizing some of the key concepts, explaining what a proof system is good at for like maybe the people that are not as technical, and then this expert audience can help specify the things we know can go wrong. So you mentioned fiat shamir, we know that weak fiat shamir is a big issue, etc. So really kind of standardizing the structure of each protocols when you make it non-interactive. This is what needs to be passed in the hash function, like to really try and remove a class of attacks that keep showing up all the time. And it feels like also with regards to Gross 16 and other proof systems, we have a bit of a shiny syndrome, shiny object syndrome, where there's always a new thing coming in and we're like, oh, look, this is so cool. But to the best of my knowledge, nothing is wrong with Gross 16. It's a perfectly fine proof system. There's a security proof for this. Nothing prevents us from standardizing it, saying what it is good for and not necessarily good for, and maybe standardizing Plonk as another thing. And then we have an array of tools that we can use for the proper use case. Because at the end of the day, if we talk about identity, of course, the threat model is very different from the case where we talk about forgeability of signatures in the context of blockchain systems where funds are at risk. So it's really use case dependent, and we will never be able to find like a one-size-fits-all approach. So for me, the only way forward is based on also what Dan said yesterday on the panel, having a rolling standardization process, taking in what is commonly used in the industry, standardizing it, making it clear that we specify what these things are good for and not so good for, and moving on to the next thing and standardizing it again and again. And then it's the developer's responsibility to pick the right tool for the specific task they have at hand.
Mm-hmm.
I belong in the next room, formal verification person, but somehow I escaped to here. And then my suggestion is to forget about the formal verification, especially in the beginning of this thing, because the standards of the hash function and so on are not a problem at all, as people are doing for standardization at the moment when I try to do formalization stuff. Programming languages are terrible, but crypto standards are okay as it's being written. Also, like formal verification is really good at like finding tiny problems in the proofs, so you don't want to check the hybrid argument all steps. So like these are like tiny details that you should care about like later in the stage.
Do you have a strong opinion on the target of standardization high level?
No, it should be like, stakeholders who are affected by the choice and the deployment of these things. That's the most important audience. And then, of course, that people who are going to implement it will also need to understand the standards precisely. But the biggest purpose is to make it understandable and helping people make nice, good choices, reasonable choices.
Mm-hmm.
Go ahead.
So I don't know. I don't have any experience with standardization, but it seems like it's very important to specify everything completely. So like the hash-based system seems very complex. Like if like growth 16 is something that fits in a piece of paper, and then it seems like hash-based will be very complicated. Then there's like lots of parameters to consider. And same thing for Plong, because like my understanding was always that the nice thing about Plong was the flexibility, custom gates and all these. And at this point where you want to fix one version, maybe like that's, I don't know how this fits together.
I saw the same thing about Longfellow spec. It fits in a really tiny web page, everything. All the assumptions, construction, everything. Wire, like serialization, it all fits. So, yeah.
To add on just that point, yeah, growth 16 is very simple and Plonk is quite simple, but it really shines with its versatility. But I think that all of this discussion also comes hand in hand with what we are doing with ZK and especially primitives. So at the very beginning, people were talking about LOMC, MIMC, they were creating their own variant of it. Poseidon, there must be many different instantiations of it with different run constants, with different numbers. People are coming back from Poseidon 2 to 1. And that is just to say that standardization of ZK, I think, is important, but the primitive we use for ZK are very different from what we usually use. And so this has to go hand to hand together.
That's very true. And in particular, I can say in the EUDI effort, there's a group pushing BBS signatures, and they just run up against this issue that pairing-based curves are not standardized and are not supported in hardware modules. So whereas like in the ZK world, pairing-based curves are just widely accepted. Yeah.
So going back to the formal verification question, so I'm not familiar with the current verification efforts in the other room, but I'm kind of familiar with the tools they use. So of course, for this purpose, Lean is the most well-known one, but there are actually several such tools. I'm using personally Agda more. Basically, all these tools are the same. They are dependency type programming languages. So they can be used both programming and proving at the same together, interleaved even. And they are also very good at specifying things. So even if you don't want to prove things, it is a really good language. I think it's the best language. I mean, not the particular languages, but the general, these are all very similar languages to each other. So maybe the syntax could be improved or the tooling could be improved, but these frameworks are actually extremely good at describing things precisely, and you can kind of choose the precision you want to do. If you want to prove things, then you need to be perfectly precise. But if you don't want to prove things, just specify things, then you can kind of choose a trade-off between precision and simplicity. So I kind of disagree. I think these are the best, absolutely best tools humanity has to specify things. So even and because of this, I feel there is a big overlap. Just even if you forget about the actual proofs. Yeah, so I think we should write specs in Lean or Agda. It's a lot of work, yes, because you have to be very precise, even if you are not proving things. But this is the same kind. Basically, you are forced to be precise, which is a good thing. When you do things on paper, then you kind of are blurry, hand-waving about things. And these tools actually force you to be precise, and at the end of the day, it will be much cleaner because it forces you to have clean thoughts. So yeah, I think they are very good tools.
I would add that the number 7 billion is maybe 95% on those blockchains that they're trying to formally verify, and the underlying technology is relying on everything we're trying to standardize here. So I think there's also an alignment from a stakeholder perspective. So they don't just care about the fact that it's very precise spec. It's also an actual security effort. So it's all in favor of combining.
Yeah. So I'm very aligned with one of the comments here that was related to how we're proving, where we're proving, and the tooling that we have available for that, and also like proving for blockchains and proving for identity. It's a different kind of word. And sometimes it's even, like, for example, if we need to prove on the browser for identity reasons, like if we're doing an onboarding and we need to create the proofs from there, like what's the tool that is available, or a tooling that are available to make that happen. And commonly, when people start and don't have like all this understanding on how the proving system works and what might be the best one, like if it's growth, if it's whatever other one, the main thing that might drive them to a selection is the tooling system that they have available for development. So, and in some cases might be the tooling system that allows them to do this, like even let's say an MVP or whatever, do it as fast as possible. And then that might be an error, but it is the thing that allows them to showcase this as fast as possible, but at the same time might lock them into a system that is not the right one for that use case. So I think that one of the things that we need to also like think about when standardizing, it's also, and that's I'm basically repeating what he said, is just like it's understanding which proving system it's right for this specific use case. And maybe that's not very clear around the actual ecosystem. It's just like not clear which one is the best for this specific use case. And I don't think that even for identity purposes, it's even less clear in some sense, because there's like not too much information around on what might be a good approach, and maybe there's not a lot of tooling. For example, in my experience, when I started like working on identity and proving and all of that, like the fastest path for me was using Noir and the ultra hung and all of that. Might be a good thing for identity or not, maybe not be the best, but it was just like the fast path from a developer experience standpoint. So that's also something to consider.
I think it's worth taking a step back anytime you think about standardizing and thinking about what is it for, right? It's coordination at different levels. And so one part is for us, this community, right? Like how do we standardize our own thinking around a particular proof or whatever we're ending up talking about? And then there's how does that bubble up to these standard bodies that are not in the room here and don't actually have that context and are thinking about it from different perspectives. And like if it's not in an HSM, it doesn't matter to them maybe, I don't know. But it's worth figuring out the dimensions for what we care about for the rest of the world to understand, and then what are the different levels that we need to dive into for ourselves. Maybe we do want the actual, a formal verification, or maybe that happens later. I don't know, but it's worth breaking this down a little bit so we don't try to solve everything with one solution.
Yeah. Were there other comments? Yeah.
Yeah, I also think one of the issues is that for some of these use cases, especially in identity, it's not really clear what people want in the first place. Like there's quite a very large spectrum of identity standards. Of course, like the U.S. government is, mostly on MDL, MDocs, so at least like Longfellow can be like, okay, that's what the U.S. government does, therefore we do this. I think for other efforts like EUDI or just like Web3, W3C and like other standards in general, it's like very unclear what people want, and a lot of the groups that try and tackle this kind of standardization, like non-creds, are like not really sure what approach they should be taking, I feel. So I feel like there's a lot of cases where we want to standardize the cryptography, but we don't necessarily know what the requirements are in the first place.
That's a great point. I think this confusion around standards is a universal experience. Maybe the only universal thing about standards. Yeah. But it's worth noting that standards are super sticky. So once something like MDL or like JWTs become sort of canonical, it's hard to get rid of them. And for instance, Longfellow yeah, they designed their whole proof system around being compatible and being efficient relative to these legacy curves like P256, ECDSA. That is super hard to change since it has been standardized.
Yeah, just one final thing, building on a lot of ideas that have been mentioned, but like it would be also quite interesting to narrow down the scope of the standardization, because for instance, we talked about primitives, Poseidon, etc. But like the minute we start talking about that, why did this primitive, what have they been like released and invented? Because we were constrained by field arithmetic, and we were like, oh, like doing bitwise operations in the field, it kind of sucks. So let's try to find something more algebraic. And then we start digging into the circuits. And for the circuit writers in the room, I mean, you guys know that we all like to optimize things, and then you do Planck and custom gates, and this becomes really kind of hard to standardize because everyone kind of likes to try to optimize things for their specific use case. So for instance, I don't know, like there's already a lot of things that can be standardized, like serializations of proofs, properly specifying the algorithms. Again, when you go from interactive to non-interactive, there's a lot of things that are used by everyone that can be standardized, like curve parameters, like on which curves do we actually, what curves do we use to instantiate the proof systems. And then we really need to be careful, in my opinion, with the primitives that we use to define like the actual statements we are trying to prove, because that's really another kind of worm.
Yeah, just to complicate things even more, you know, in blockchains, we generally optimize for verification speed and size because that's what's expensive to us. But a lot of the pushback on the guidance from the EUDI, for instance, from like Germany, we're like, we have to generate 100 million records day one, and depending on what the unlinkability solution is, it might be 100 per person. And so they have to pay a ton for proving, and they don't necessarily care about verification because that's, you know, that's going to happen on normal servers in normal Web2 businesses. So, and you know, as you mentioned, the blockchain space has kind of aggressively shied away from government-approved cryptographic schemes, but that's all that these governments use. Like a lot of the optimizations we made in proving systems just don't apply to them.
Yeah, but we're all going to explode when quantum will. So we're aligned on that, right?
Yes, I think a common theme emerging from this discussion is the need to narrow the scope of our standards relative to their intended audience. And I want to share some of my experience with these standards bodies, and they are very, very different.
Officially we have 5 more minutes.
What? I thought I had 40 minutes for this.
Okay.
Oh, that is 40 minutes.
Yeah, sorry.
Okay. So yeah, I guess John, you were saying it's worth thinking about the role of ZKProof standards in this landscape of standards bodies. So yeah, I have engaged with the IETF and the W3C. So what I learned from the IETF is they want something very specific. They want basically to reduce choice as much as possible and reduce ambiguity for the engineer who's going to who implement this standard. And so they want a concrete protocol, and they want down to the serialization on the wire. And so
they need embodied standards, right? Like actually.
Yes. Like for instance, this Longfellow standard I mentioned just now, it fits in one very short web page. The thing is that it's not going to be reusable for any other proof system. And we see in practice in our community, there's libraries like Artworks that are generic over different polynomial commitment schemes, different fields, and it is a common practice in our community to compose these different primitives in a modular way. So, yeah, I found that IETF considers this kind of a meta standard, and they really don't work that way. Whereas the W3C actually is more compatible with that approach. So, for instance, they have a maybe meta standard called VC, Verifiable Credential Data Integrity, and then they have multiple instantiations of it, like with ECDSA, EDDSA, BBS signature. And this is a more, I think, compatible with the modular approach. But this is just something I learned, that different standards bodies approach things very differently. And then, yeah, so I think besides that, we have NIST as well, who focus on lower level primitives. They did have a call for zero-knowledge proofs of knowledge as part of their multi-party threshold scheme call. And then we have, I see ZKProof standards as kind of incubation. So, for instance, Linux Foundation also has these labs where they have the support system to set up working groups, and they have communities that are interested in ZK. And the idea is to use that momentum to come together on a spec that eventually we can submit to IETF. Yeah, so
on the topic of NIST, we actually for quite a while we were expected from their end to offer to them maybe pointers to both the applications of zero knowledge, but also the concrete places where industry is using particular embodiments to allow them to then maybe further down bless particular primitives. The effort you mentioned that was part of the threshold call for paper was basically like a first dip in this area.
Yeah.
But I think the times have changed a little bit there. I think there is more maturity to consider zero-knowledge proofs as their own, let's say, field. And I think the fact that a Google goes into the room and picks a candidate and pushes it forward is like a big event, also for NIST to note. So for us as a community, we do need to figure out what concrete outcomes we bring from these discussions. This year, we did kind of take the time to get a lot of new papers and a lot of novelty in the space. You saw that this conference is very focused on a lot of new developments, but these efforts require continuous work throughout the year, not just at the conference. And we actually have, at the steering committee level, we have a plan to approach the community, those that are active, and try to figure out what would be our recommendations for a NIST and for a W3C. It's a double-edged sword to be this incubator of standardization, because if we sit on this square and we occupy it and we don't help push forward those standards, then others won't do that effort, or not as with the same potential to succeed. These are the people that know exactly the space. They're in the room and the room next door. So it's our responsibility to go and produce those outcomes. Unfortunately, this is it's a small organization. We rely on the collaboration of you guys to help us with that. So we will do an outreach to understand, now that the stakes have gone significantly higher, how to help those outside standardizing body to hone in on the right approach.
Yeah. So I think to sum up, there's already lots of efforts ongoing in standardization, and I think our community has already reached out to IETF and W3C. Probably people here are familiar with Spongefish, and it has a corresponding Fiat Shamir spec that has been accepted to IETF, for example. So I think there's really lots of reason to be optimistic. Even though it's a hard problem, I think, as John said, it's very urgent. And yeah, I look forward to the discussions in the coming months. Thank you.
In particular, if you have ever submitted a paper to ZKProof and were accepted, we might reach out to you to gather your thoughts on this specific topic. So that's many of you in this room as well. Okay.